Another useful tool in vZoom is to display and list the turning movement volumes. To create a plot of turning movements, first enter the graphic parameters and open the turning movement parameters. You will need to make sure the Draw Turn Volumes, Draw Bars, and Draw Bars labels are selected with a checkbox. Next, open the graphic parameters for the turn volumes and left-click on Display. Here, the default scaling attribute needs to be modified to something meaningful for the plot, such as the vehicle volumes from the assignment. Once satisfied with the basic graphic parameters, click OK and then select Turn Volumes in the Graphics menu. This opens a dialog which allows you to access the graphics parameters, reset the radius of the labels and bars, as well as turn on and off all turning movements in the network window. We'll select a node and notice the turning movements that pivot on the selected node are displayed. If we left-click again on the node, it toggles the turns off. We are able to choose the turns we want to display in this manner and then plot them as we would any other display. vZoom includes a post-processing procedure based on Chapter 8 in Report 255 of the National Cooperative Highway Research Program. In short, this allows us to account for differences between model output and field observations and then apply correction factors for forecast scenarios. To implement the NCHRP 255 process, go to the Calculate menu and click on Procedures. Next, create a procedure, and in the Miscellaneous heading, choose NCHRP 255. Now, click on the Parameter button, and this opens a dialog for defining input and output link and turn volume information, as well as the method to adjust the volumes. In the Adjustment Method drop-down, select Combination and keep the default values in the Boundaries section that became active when we selected Combination. Notice there are 4 models of adjustment, and for more information on each of these, we'll refer you to the NCHRP 255 document. Next, select the attributes for the counted and base volumes. Often we are executing this process in the forecast scenario, so the future assigned volume is the assignment output, but if you want to adjust based on any other attribute data, you may select it. Define your output data and click OK to accept the parameters. With only this operation active, click Execute and then inspect the adjusted turning movements and link volumes in the network and listings. In vZoom, we can compare the data between 2 version files in a difference network. In essence, the difference network is just as it says, one version file subtracted from the other. vZoom retains the attributes from both networks as well as the difference between them. In this lesson, we'll learn how to establish a difference network and graphically present data for plots. In the File menu, select Difference Network. This opens a window where we establish the version files that we will subtract from one another. In vZoom, version file 2 is subtracted from version file 1. We have the option of loading a predefined graphic parameters and filter file as well. We may save the parameters defined in this dialog by clicking Save. Once saved, we can call this file by clicking Open. Once we're satisfied with the file information, we can click Execute. The difference network is now active. You can display attributes in the same way as you would any other graphic parameter, although notice now you may select attributes for the first or second version files and the difference network. We'll establish one display to evaluate the change in capacity on a corridor of interest. And now, the differences in the assignment output by showing the differences in link volumes. Isochrones are a way to view a travel time metric on network relative to a specific place. Often this is helpful in a travel time study or checking network coding for reasonableness. To establish an isochrone, open the graphic parameters and go to the 2D display. Here, you specify the attribute and object you want to display. Use the drop-down to select the object. We'll choose Nodes. For the attribute, we'll select Isochronos time PRT. You then may select the intervals in the classification on the right along with the colors for the stratification. You may elect to have smooth color transitions and different picture quality as well. Once the parameters are established, we accept them by clicking OK. To make the isochrones active, left-click the Graphics menu and select Isochrones. A dialog opens that allows you to specify the transport system. We'll select Private Transport. We will use the constrained travel time, T-cur. Then, click a node. Notice the network is now displayed with colors that show the amount of time it takes to reach a point in the network. If you click another node, the displayed result is the isochrones when considering both nodes. To reset, click Initialize, then select a new node. You may close the dialog and the current isochrones will remain active. You must initialize and then close to reset the graphic.